starting. All attendees are in listen-only mode.
Good day, and welcome to our webinar, Don't Be Penny-Wise and Workstation Foolish, presented by Cadalyst. This is Nancy Johnson. I'll be today's moderator. Our headliner today, of course, is Robert Green. For most CAD managers out there, Robert needs no introduction, but it deserves mention that he has been sharing CAD management advice and expertise for almost 20 years through literally hundreds of newsletter and magazine columns, as well as his book, Expert CAD Management, The Complete Guide, and as a speaker at Autodesk University, and of course, through all his consulting work. It also happens to be Robert's birthday today, so happy birthday, Robert. Another reason today is special is that we here at Cadalyst developed today's event with Robert to build on the connection that he has with the CAD management community. It's not often that most people get to engage directly with Robert, and we feel this will be a great opportunity to do just that. We are not here to promote any particular company or brand, but rather for Robert to share his advice and other information that he knows to be genuinely helpful for you, the CAD managers, CAD users, and your companies. So we hope that you find value in this approach, and we hope that today's event will be the first of many. Now, having said that, in this day and age, it's helpful to have a sponsor for production such as this one. And our sponsor today is Fujitsu, which is a provider of desktop and mobile workstation technologies throughout Europe and Asia. We are very grateful to Fujitsu for its support of our new endeavor. So real quickly, before I hand this over, I have a few housekeeping details for all of you. The obvious question, will today's presentation be recorded? Yes, we'll make it available to all registrants within the next 12 to 24 hours. You'll receive an email when that's available. Our webinar today will conclude with an extended Q&A session with Robert. So at any time during his presentation, submit your questions using the questions pane that you find in your GoToWebinar control panel. And we will give priority to questions that are directly related to today's topic on CAD workstations, but feel free to submit your questions on any CAD management topic for Robert, and we'll tackle those if time permits. Lastly, as I hand this over, you will see Robert pop up on his webcam, and if that's something new to you in the GoToWebinar format, you'll notice that you also have a drop-down menu at the top of your screen that says webcams, and you can reposition the format of your screen to move Robert to the side, or you can undock him and move him over to another screen, whatever works for you to make the presentation comfortable. Okay, so let's get right to this. It is my pleasure to introduce our presenter, CAD management expert extraordinaire, Robert Green. Robert, take it away.
Thanks very much, Nancy. Hoping everybody can see me and hear me out there. Thanks for attending. You know, I made a comment once years and years ago that some of these guys are just, they're penny wise and pound foolish. You know, it's an old Ben Franklin quote, I believe. And kind of generalized that to be penny wise and workstation foolish. And the conclusion that I've definitely come to is that we experience a whole lot of companies out there that are forcing very expensive labor to use very antiquated tools. And so what we wanted to do with this presentation was to talk to you, the CAD manager, the CAD administrator, the IT manager, and try to give you some ammunition to understand how proper workstation architectures can be justified financially, and how you can get your boss to provide these new tools that are going to make your people more productive. And when I talk about your people, I mean really CAD-centric users, both from entry-level 2D all the way up to advanced 3D and analysis. So we'll go through a variety of scenarios here. Let me go ahead and advance. So what we'd like to do first is get to know a little bit about who's out there so that I can tailor the talk a little bit. So we're going to go ahead and run a few quick poll questions. And you should be seeing that show up on your screen momentarily here. And then, there we go. So first question, do you have trouble getting your company to purchase computers that are properly configured for CAD-related work? And of course, you can see the options there. So go ahead and click whichever one describes your situation. And then momentarily, we'll go ahead and close the polling out, and we'll all look at the results. So it appears that a lot of you have got this reasonably decent shape. The somewhat challenging to big challenge is a little more than half, and generally responsive. Yeah, okay, so that's pretty good. So it's not as bad as it might be in some cases. Let's go ahead and advance to the second question. And that would just be, if you were to procure a new computer or workstation for the average CAD user in your enterprise, what would the budget for that person be? Let's go ahead and click which one's appropriate there. Okay, so fairly wide distribution. Principally between $1,500 to $3,000 per workstation, and a few on the budget end. Okay, good, that helps. And then one more demographic polling question, and I should be able to tailor the talk a little bit to what we see. So if you had to guess, and be on the conservative side here, how many minutes per day would you say that your average CAD user wastes just due to computer problems, slow processing, crashes, hang-ups, etc.? Go ahead and pick the one that makes sense for you. And this will be interesting to see how this one comes back. Okay, that's very interesting result there. Try to take a mental snapshot of that, and we can see how much time really is being spent waiting on sluggish, slow, substandard computers and workstations. Very good. Thanks for sharing your information there. And that should be very instructive as we move forward. So I'm going to go ahead and start off with this. When is spending cheaper than not spending? Now, if you ask that question to an accountant, they're going to tell you never. They're going to tell you that spending is always worse than not spending. And the default answer is therefore, to any question, I need money for fill in the blank, the default answer to that is always going to be no, because not spending is better than spending. However, here's my answer. If I can save enough time to pay for the spending, then it's actually cheaper. If I can save more user time than the computer costs, then it actually makes more sense to get a computer for the user than it does to do nothing. Now, that may make sense when you say it just that way, but then the accountant is going to have this nasty habit of saying, prove it. And so that's where I want to go next, is trying to giving you some metrics and a way that you can really make a well-stated financial case for why you need to spend money on computer hardware. So let's go ahead and start digging in and having a look at a few specifics. Now I'm going to go ahead and state this because quite a lot of the time it seems to get overlooked. And this obvious statement to me is people are very expensive. Why is it that companies, they don't bat an eye at hiring 5 new people, or you'll always hear, well, we need more staff, or we need bigger headcount to handle that, or whatever. But if it comes down to buying a few new computers, which are going to cost far less than a single employee, that's too expensive. Well, what we're going to try and do is flip that conventional wisdom on its head by saying people are expensive, workstations are cheap. People are expensive, workstations are cheap. So let's dig into this a little bit. Let's consider a theoretical employee here, and I'm going to call him Bill. Bill makes $70,000 per year. Well, he really doesn't make $70,000 per year because benefits and embedded cost of taxes and such are going to add at least 20% to what your company is paying Bill. So the $70,000 per year employee bill is really the $84,000 per year employee bill. And that's the first thing that we've got to look at. People are expensive, and not just in salaries, but in overhead and benefits and other items that add to their embedded cost. But consider the fact that if Bill gets 2 weeks of vacation, he's really only working 48 weeks per year, because everybody gets about 2 weeks off for Christmas and Easter and all that kind of stuff. And then 2 weeks of vacation, so that brings you down to 48 work weeks, or 1,920 hours per year of actual labor. Now, if you do the math, that means that Bill is really costing your company $43.75 per hour. And that is cost. We're not talking about what Bill bills at, or what you might send out invoices for Bill's time for. This is actual cost. Every hour that Bill sits there is $43.75, and there's just simply no getting around the fact that employees at that level of compensation really do cost that much. They really do. So you probably in your enterprise have an idea what various people at different pay grades and different job descriptions are making. So you can do your own math here, but hopefully I've showed you the equation. It's pretty straightforward to figure out what people's actual hourly expense is going to be. Now, let's move forward on that. And let's talk about the wasted time that adds up. Now, when we polled everybody, we saw that quite a few people reported substantially more than 15 minutes of waste per day. So I'll just use 15 because it's minimal, and it's something that we can all use as a sample calculation, or a way to quantify this. So if Bill loses 15 minutes per day due to crashes, slow rendering, etc., well, that's 75 minutes per week, or 1.25 hours, and in 48 weeks, that tallies up to 60 hours. Now, at Bill's labor rate, which we talked about before, that 60 hours is going to add up to about $2,625 in a given year. Or if we were to look at it over a 3-year time frame, that's $78.75. And the reason why I always go for 3 years, by the way, is because almost all workstations are warranted for 3 years and can safely be considered 3-year property. Now, that doesn't mean that workstations may not run for more than 3 years, but it's a conservative cost basis to use. So that's why you'll tend to see me do calculations that span out to 3 years. Obviously, your mileage may vary and your calculations may be a little different, but this should suffice for an example case for us. Let's go ahead and move forward. Now, here's the question that I want to go to my senior management staff with. Why is it that we're happy wasting $7,875 over 3 years to sit there and have Bill watch a frozen, locked up, sluggish, slow computer, when a $3,000 workstation would simply wipe out or eliminate all of Bill's problems? Now, I realize that the $3,000 level is a little high for many people, and we saw that borne out in the polling slide. But I've been using the rule of 3,000 for years and years and years, which is a $3,000 workstation is typically a pretty nice CAD seat. So I'll just continue to use that for my benchmarks. And if this seems a little high to you, well, we'll still do the math, and then you can always reduce your workstation cost if you need to. Your math will even look a little more persuasive than mine will in this example. Now that we have an idea how expensive labor is, let's look at how workstations are actually a cheap solution to our expensive people problem. Workstations are cheap. I've been doing CAD myself for a long time, and I can tell you the computers that I used to run that cost twice as much as $3,000 were nothing like they are now. So when you look at the performance you're getting, they really are cheap. They really are. So let's go ahead and look a little bit at some of the performance characteristics of inexpensive workstations that I would like to at least call your attention to. We're in an environment now where quite a lot of the processors in these workstations are going up and beyond 4 gigahertz in speed. And even if their base frequency isn't at 4 gigahertz, they almost all turbo boost beyond 4 gigahertz. Workstations are going to give you the capability to add in, at minimum, 16 gigabytes of RAM, but almost all of them now will go substantially higher. Up into 64 is almost a practical minimum that is supported in workstation architectures now. Some workstations support quite a lot more. Solid state disks or SSD drives at about 500 gigabytes in size, and now almost uniformly supported on workstations, and some with the fast PCIe interface technology that makes them about 4 times faster than the SSDs we've been used to in prior years. These things are big enough now that the operating system, your CAD software, and your working projects can live on that solid state drive. So there's absolutely no mechanical delay that we would associate with a conventional hard drive. From a graphics processor point of view, a 2 gigabyte professional graphics processor, essentially considered as minimum, but workstations are going to give you the capability to go far beyond that. Now, for the sake of cost control, what quite a lot of my clients do is they run their existing monitor hardware, with most of which is certainly flat panel, and most of which is at least at HD level or 1920 resolution, and they just simply start replacing their monitor hardware on a 5 or 6 year interval. That's fine. I don't mind using a 4-year-old monitor, but I do want that new workstation. If we take all of these things together, you're going to be able to put together a workstation with these type of attributes easily for $3,000. In fact, if you go bargain shopping, you may be able to do substantially better than $3,000. But these are the attributes and the characteristics that workstations bring to the table, and at a price that really is cheap for what you get. Let's look at the cost over 3 years that it will take us to put a workstation in place. Well, if we buy a $3,000 workstation, it comes in a box and somebody has to install it. So if we look at 3 years where the user is expending 1,920 hours per year of labor, that means that we're going to be using a $3,000 workstation for 3 years, 1,920 hours per year. And if you do the arithmetic, that comes down to 52 cents per hour. You remember what Bill's labor cost was? It was $43.75. So the workstation cost is about 1% of Bill's labor. Now think about that statistic and think about how compelling that number is. For roughly 1% of additional cost, you can put a really, really nice workstation on this person's desktop. Now, what we want to do to move forward from this idea of people are expensive, workstations are cheap, is we want to move to an investment-based argument that we can take to our senior management, and that's ROI, or return on investment. And the governing equations here that we need to be concerned with is that time equals money, and savings should always be greater than costs. Because if I save more money than it costs me to fix the problem, I'm going to be receiving a positive investment. So what I'm going to do here is I'm going to tally up the savings from typical problems that I see around the enterprise, like time spent rebooting, time spent waiting for processing, slow, sluggish video performance, slow, sluggish plotting performance. All these things are processor and RAM intensive tasks that simply run slower on a slower old machine. Another thing about older hardware is that they tend to have conventional hard drives as opposed to lightning fast solid state disks. So even if the computer is equipped with a decent processor and amount of RAM, they're still slow simply due to a hard drive. So that technology is very limiting. If I can get rid of these types of problems, it's going to add up. And the time adds up over a year, it adds up over 3 years, and we can start making a computation. So let's go back to the case of Bill. Now, 15 minutes of wasted time added up to $26.25 per year, right? And there's the calculation. That's exactly how I got it. Just 1.25 hours per week, 48 weeks a year, 43.75 per hour. So this is an equation, if you will, that you can plug in. You replace the 15 minutes of wasted time with what you experience. You plug that in to 48 weeks per year of labor and your user's labor rate, and you will arrive at a number. Okay, so simply do the math using your labor rate and the amount of time saved for your user, and you will very quickly get to a number. That number becomes the compelling argument that we need to take to our boss. So let's go ahead and tally it up. A new workstation, let's go use the $3,000 price level that I suggested before, and let's assume that IT has to install it. And let's assume that IT is going to require 2 hours to install this workstation. We'll assign it a $65 per hour labor cost. Now, obviously, your IT department may be able to do this in 1 hour, but their labor rate may be higher. I don't know. So you're going to have to go ask your IT department how much to include. But you should arrive at a number. In this particular case, my computation comes out to $3,130, and that is purchase and install. So it's total cost for implementing the workstation. If we go ahead and take the numbers here and look at a 3-year return on investment calculation, we'll kind of get to some staggering results. Now, return on investment is simply savings divided by cost, which in our case was the time savings that we could generate for Bill over the total cost of Bill's new workstation. In our particular example here, the time savings for Bill over 3 years, $78.75 divided by workstation cost, $31.30. Now, this yields some staggering math. 252% return on investment over 3 years, or annualized at 84%. Now, what I want you to do is think, if you could walk into the bank with $3,130 and deposit it and come back 3 years later and they would hand you $7,875, would you do that? Because I sure would. I mean, the stock market doesn't make anything near that, even in boom years. This is a great investment, and that's what I want to talk about. So hopefully everybody saw how we did that, and we'll actually have a worksheet that's available that has gone through these sample calculations that you'll be able to download. Some of you may even see it over there in your control panel. There's a PDF file. And that is a worksheet that goes through these sample calcs for you. Now, the next step is pretty obvious. Go to your boss. Show your boss what you've come up with. Key, you have to explain the savings potential, how much time your users are wasting sitting there waiting on an old workstation. You then outline the cost of new workstations, and you fully acknowledge, look, I know you don't want to spend $2,000 per user or $3,000 per user, but here's the return on investment scenario, and here's why you really do want to go out and buy these new workstations. So I started doing this almost by accident early in my CAD management career because everything I had asked for, the answer was no. So what I started doing was benchmarking wasted time. And then I would have a vendor bring in a demonstration unit for a plotter or a workstation or something like that. And we'd have users sitting there singing its praises, and we'd have, ROI studies like I've led you through here. And you go to the boss and they start validating and asking people, wow, was it really that much faster? And yeah, it really was. It saved us a ton of time. And then project managers start talking about it. And once you start having this conversation with senior level management, they start to see that the workstation really is a cheap solution to their problems, and that people or additional people may not be as valid an answer as equipping your existing staff with some really bang workstation hardware. It's a little bit different way of speaking about it, but trust me, it works. And the reason why is because your boss speaks money. As CAD technologists, we tend to speak CAD, but your boss speaks money. So what I've done here is I've tried to make better workstations make financial sense, the core argument. And if you do that, I think you'll find your boss is extremely receptive to it as well. So let's move forward from here. Now that we've got a basic financial argument, let's just talk a little bit about some available technology that's becoming, becoming more universally supported in workstations now, and really differentiate the workstation market from, let's say, a consumer computer, and how that might make a difference to everybody from, let's say, an AutoCAD user who's strictly in a 2D mode of operation, up to somebody who's doing pretty decent Revit modeling or Civil 3D or point cloud manipulation that really does require a lot of horsepower to run. So one of the first things that I always get asked by any management team that I go and talk to about workstations is say, look, why don't we just go buy something off the shelf? These workstations, it seems like they become obsolete in 6 months anyway, so why don't we just go buy something cheap and be done with it? Well, my answer to that is the reason that the things you're buying are obsolete in 6 months is because you're buying something that's obsolete in the first place. When you go buy a consumer level PC off the shelf, it's already, it's just absolutely cooked from an obsolescence point of view. It's already an obsolete processor. It's already undercapitalized in RAM. It doesn't have the high performance disk subsystems and peripherals like we'll talk about in a moment. You're simply not going to get the types of features and configurability in a consumer level PC that you're going to get in a workstation architecture. You're simply not. It's like the difference between, buying a Yugo or a BMW. It's a huge difference in terms of the performance that you're going to get. So let's talk a little bit about the components and some of the attributes that we want to be looking at. For CAD use, and I'll differentiate this a little bit later, whether it's AutoCAD or Revit or Inventor, for the most part, these applications work on one processor core. Now, it's not always 100% true, but for the most part, they run on a single core. So therefore, the clock rate of that core is the most important thing. Now, I would specify either Xeon processors or Core i7s. I tend to stay away from the i5s and the i3s because they don't have the clock rate, they don't have the memory architecture, some of which we'll get to in a moment. So those are basically my preferred processor families. What you want to look for is the highest base and turbo boost speeds that you can get. That always makes the most sense. This is kind of the one thing that can't be upgraded later, so get the processor right. Right now, I wouldn't buy anything that really clocks below 4 gigahertz. There are too many options right now that are faster than that, so there's simply no reason to go lower than that at this point. Okay, so what we want to do is at least have boosted speeds above 4 gigahertz on as many cores as we can get on the machine. We want those cores to support the fastest possible memory, which I'll talk about in a moment. And if we do this, what we will do is we will get a processor that is fast. It forms the basis or the heart of the system, if you will, and it's something that you really can't pull out and upgrade later in a very convenient or cost-effective way. So do not skimp on the processor. Let's look at what's next. RAM. Okay. At this point, I would consider RAM 16 gigabytes a practical minimum. The memory technology should be DDR4, and it should be running at least 2400 megahertz. This will get you into the last generation of Xeon and i7 processors, the new generation just starting to come out, going up to 2633. So the goal is to get the memory as fast as you can. Use the highest speed RAM that your processor can support. Fill all the memory slots on the motherboard equally. So if the architecture of your workstation has 4 memory slots, then fill all 4 of them. So for 16 gigabytes, that would be 4 4-gigabyte modules. All slots are to have the same size, same speed of memory. That will give you the best possible performance for your memory, and there's simply no reason to buy a fast processor that can use faster RAM and boat anchor it with something slower, particularly when memory is only $20 to $25 per gigabyte at this point. So again, don't skimp. 16 gigabytes should be considered the practical minimum. Let's look at the solid state drives, or what is now replacing the hard drives that that we've all used. These solid state drives, they basically eliminate disk access time. By eliminating disk access time, they speed up everything. The computer boots faster, software loads faster, files save faster, they open faster, they process faster, everything gets quicker. And what's really interesting to look at is if you ever look at the performance monitor and watch how your processor is performing. On an older machine, the processor performance will dip way down as it waits on the hard drive. A machine with a fast solid state drive, the processor will remain pegged and highly utilized. Now the new technology in solid state drives is called NVMe, and this is far preferred over the older SATA 3 drives that have been in machines in a couple of years back. These tend to go in an expansion card in the workstation. They're worth it. They do cost a few $100s more. They're worth it. They perform about 4 times faster than the old SATA 3 drive technology, so it's a really meaningful upgrade. $200 over the cost of a $3,000 workstation is not that much. But even if you do have to settle for a SATA 3 technology solid state drive, don't buy a workstation without a solid state drive. It's the best bang for the buck upgrade you get anywhere. I would far rather have a cheaper graphics card and get a solid state drive than the other scenario. So it should be considered as an absolute must. Your graphics processor unit, or GPU, go with something that is certified. Now, I will sometimes get people argue with me, well, you could use a gaming card, and it's true, you can, but it doesn't mean that it will be certified by the software vendor. It doesn't mean that you'll receive any kind of timely updates, or that you'll get any better warranty support. Whereas if you go with something that is certified, it comes in the workstation, it's going to carry the same 3-year warranty support that the workstation carries. And by virtue of it being certified, the software vendors are going to make sure that it works with their software moving forward. So, staying with a NVIDIA or an AMD professional graphics processor, while it does cost a few more dollars than a gaming card, I think on balance, you're going to see that the performance you get, the fewer glitches you get, the better performance over the 3-year lifespan of the workstation are going to be worth it. And that's why I do recommend that you go with something professional and certified. Let's talk a little bit about peripherals. Any computer should have ample USB 3.0 technology ports on it. Now, a lot of times there's a lot of USB ports, but there may only be one 3.0 port and a lot of 2.0 ports. The 3.0 technology is much faster. So for things like external hard drives, you're going to see a definite performance difference. Better still than USB 3.0 is Thunderbolt, though. And I've got a graphic that shows Thunderbolt. Basically what Thunderbolt is, it's kind of like USB on steroids, but it can do so much more than just move data. It can actually transmit power. It can run external processing cages. It can actually run external monitors, external docking stations, etc. So Thunderbolt 3 is really a game changer in terms of external peripherals. And it's something that if you can specify it right now, you're going to be glad that you did. Another emerging trend, which we're starting to see from some of the new Intel mainboard sets, is the advent of 10 gigabyte networking. Now, this is a factor of 10 performance difference over the 1 gigabit networking that is in most workstations today. So if you have workstations that have huge data sets that take a long time to move around networks, the 10 gigabit architecture is something that will clearly pay dividends down the road. Now, that's a new technology, and you're just really starting to see it on some of the new workstations that are coming out now, but it is worth having a look, or at least having your IT department to have a look at it. Increasingly, what we're seeing is that it's not just how fast the workstation can do its job, it's how fast you can get the data on and off the workstation, especially when we talk about heavy data set scenarios like video editing or point cloud collection in the field. It really makes a big difference. So you want to start looking at making sure that any peripherals you plug into your workstations are nice and quick. Now let's go ahead and have a look at what I would consider to be a minimum CAD configuration at this point. I would say a 3.6 to a 4 gigahertz Core i7 processor that will get you in the upper range of that processor architecture. Something like a 6700 or a 6700K i7 processor. 16 gigabytes of DDR4 RAM at the highest speed the processor supports. A 500 gigabyte SATA 3 solid state disk, and a 2 gigabyte professional graphics processor unit or GPU. This should give you a useful, if not luxurious, but a useful 3-year lifespan on this workstation, and something that's clearly going to support, an AutoCAD or a lightweight 3D workflow. No problems there. Now that we've looked at the minimum, oh, and I guess one thing I should say is please notice that my minimum is way, way, way more than what the software companies will tell you is a minimum. Now that we've looked at minimum, let's look at something a little bit better. At this point, you can start looking at some of the new Xeon series processors that are coming out, and it's differentiated a little bit now in that they're going things like bronze and silver and platinum and gold. But these processors can start to reach base level core speeds at 3.7 gigahertz, and they turbo boost up to 4.5. This could get you into a Xeon 6-core processor, which is going to give you a few extra cores to absorb more aggressive workflows that may be coming in the next 3 years. I would consider 32 gigabytes of DDR4 RAM to be a better choice on this one. And for the solid state disk, definitely make sure to go ahead and step up to the NVMe technology, which will get you much faster, that 4 times faster performance than the older style drives. Consider going to a 4 to 8 gigabyte graphics processor unit. Now, hint, this is one place where you can save a little bit of money, because if 18 months from now you have to pull out a graphics card and put a new one in there, that's not the end of the world. That's not like buying a new workstation. So you can take your best guess now and upgrade later on the graphics processor if you have to, but don't skimp on the processor, RAM, or the solid state disk. This should give you a high performance functional 3-year lifespan. So this should be a nice aggressive CAD workstation for Revit, mechanical modeling, lightweight visualization, those types of things that more aggressive CAD users are going to be using, and it should suit them well for 3 years or so on their desktop. Let's look at a few task-specific adjustments because, sometimes some people just need a little more performance than everybody else in the crowd. So one of the things that I see happening more and more is really intensive analysis or video tasking. As video has exploded and gone up to 4K, and now we're seeing 8K, the amount of processor time and graphics horsepower that's required to perform these tasks really has started to make this a much more aggressive application. In these cases, a lot of these applications really can take advantage of more cores. So a 6 to 8 core processor can help with those multi-threading applications, more applications, and some that are multi-threading. Keep the clock rates up on the processor as high as you can, and do consider 32 gigabytes of RAM to be the practical minimum for these types of tasks, with 64 being better, for sure. At this point, you probably want solid-state disk, definitely NVMe technology, and you probably want more like a terabyte of that solid-state disk base. The GPU should be dictated really by just the resolution that you're working at and the frame rates that are required. For example, if you're trying to do show and tell video rendering at standard HD at 29 frames per second, that's totally different than trying to do 4K resolution at 90 frames per second that's required for something like a set of VR goggles. So let your application dictate the GPU that you will get. Now, at some point, your boss starts to say, hey, wait a minute, this stuff's running up the price tag here. You know, your $3,000 workstation is now a $4,000 workstation. Well, talk about the time savings, you know, because running a really high-end rendering job would take 4 or 5 hours using the older machine. We're now going to get that done in 1. So we're going to be saving our employee quite a lot of time and pretty quickly. High-performance mobile workstations. Let's talk about that a little bit. First of all, the same recommendations as the desktop. I mean, just because somebody's on the road doesn't mean that they need less of a processor or less RAM or less, less solid-state disk. So basically, they are kind of the same requirements. We definitely want the high-speed peripherals for things like externalized hard drives, externalized battery capacity. It's typically something that's really good to look at. And the time saved here will quite frequently be the amount of time that it takes to get data on and off the mobile workstation. And then if we can also process fast by having high-performance processors and RAM on the mobile workstation, it's going to justify the expense. Now, obviously, a high-performance mobile workstation is going to cost more than a consumer laptop, but the time savings justifies it. Let's start moving to kind of close out here, and then we'll go ahead and take some questions. My recommendation for purchasing hardware, buy for next year, not this year. If you buy workstations that are appropriate for what you're doing this year, it'll be obsolete next year. So go ahead and buy hardware that's a little over spec, because you want this stuff to be functional for 3 years. So purchase robust systems simply to prevent obsolescence. Are you overbuying? Yes, you are. But can anyone here in this audience ever think of a time when files haven't gotten bigger, applications got larger, and their processing requirements to do CAD haven't gone up? I can't think of it. So clearly we're going to need more computer next year and the year after that. So why not just buy something robust enough in the first place? Today's rendering machine, the thing that's really hardcore, really bang bang, that really processes in a huge way, is probably going to be a pretty nice CAD machine in about 2 years' time. So there's just this realization that obsolescence occurs and that machines are going to slow down relative to the software tasks that we need to perform. So for this reason, I like to recommend plan for multiple owners. Buy new rendering machines every 2 years, right? Not 3, but 2. And then put those new machines on the high power rendering users, and then after 2 years, take them away and put them on a CAD user's desktop and run them for another 2 years. Then, after it's no longer all that acceptable to run CAD, take that machine and run it as a general office machine. Do word processing on it, and run the barcode scanner out of the shipping dock with it, and just simply run it until it dies. This way, you get bang bang performance for 2 years, you get solid performance for another 2 years, and then you get general office performance out of it until it dies. you may very well get 5 to 6 years worth of useful performance out of a workstation. And the workstation will always be on the appropriate user's desktop. Never buy a low performance machine. Buy a high performance one and rotate the old machines down to lower performance tasks. Which leads me to another conclusion. Let the labor cost of your user dictate your workstation purchases. Buy the new rendering machines every 2 years. They're the most expensive, and put them on the most expensive people's desks. Let me restate that. The most expensive and newest machine should always go on the most expensive employee's desk. Okay, because those machines are going to be the one that justify the cost savings, right? Run the machine as a CAD user for another 2 years, where its diminished lifespan will still serve you well, and then just run it until it dies to milk every last cent worth of performance out of it. So in conclusion, and moving towards the Q&A session, and so Nancy will hop back in here with us now, I think. What I'd like to leave you with is kind of this thought. The workstation is a professional tool. It pays your company back. It's not an overhead item. It's not like a photocopier. It's not like a desk chair. It is actually a professional tool that makes your employees more effective and more productive. If you do the math, you'll see that matching the workstation to the user workload actually saves your company money. And if you can get rid of that wasted time that we quantified in that polling slide towards the beginning, I guarantee if you take that study to your boss, they're going to see the wisdom of it. Keep having that conversation, and I think you'll start getting your new workstations. So Nancy, are we there? Maybe not. We're having a little bit of phone problems. Nancy, can we hear you? Let's see. Well, I guess I'll have to have somebody send me some questions, I guess, on the.
Thank you, Robert. That was a really great presentation.
There,
with lots of great takeaways, as usual. So let's move right into our Q&A, as we've had some questions coming in for Robert already. Just as a reminder to attendees, please submit your questions using the question pane in your GoToWebinar control panel. And we will give priority to questions directly related to CAD workstations. But feel free to submit questions on any topic, and we'll tackle them if time permits. And don't forget about the included handout, Robert's Workstation ROI Calculator, which is downloadable via your GoToWebinar control panel. We will also include a link that you guys can download that from. So our first question that we have for you today, Robert, is I'm in a smaller department. We have 4 heavy CAD users, 4 dabblers, and 3 non-users. We get high-end computers for the heavy users and very capable computers for the rest. Is there a better strategy?
I think that's probably the best strategy. What I would do moving forward is to buy the 4 heavy-duty workstations, say, on a 2-year interval, as I'd recommended. So let's say 1 year from now, 2 years from, I don't know how old your machines are, but whenever that interval comes up, buy 4 really nice machines for those 4 power users and take their 4 computers and move them down to your 4 dabblers. What that should allow you to do is buy 4 even nicer workstations every few years. That would be the only recommendation I would make. It sounds like you're doing the right thing.
Okay, thank you. The next question we have is, can we speak to the difference between software applications, CAD versus Revit, and how the processor specification may be better for CAD versus Revit or types?
Right. So if we look at AutoCAD, or we look at a Revit, or we look at a SolidWorks, or an Inventor, for the most part, those are pretty lightly threaded applications. They may be doing some things, like AutoCAD may be spawning off some visual style processing to another core or to the graphics processor. But for the most part, they really work on one central core which is getting the most of your turbo boost performance. So really for all those types of applications, typically a 4-core, at least for now, a 4-core processor that has the highest possible clock speed is your best choice. Now, if we start doing a lot of tasks in parallel, if we're doing a Revit model and at the same time we're running a solar analysis module, and at the same time we're running a visualization module, or we're trying to render something in Camtasia off to the side, now what we've got is a variety of processes that are running, and at that point you want to look at having perhaps a couple of extra cores and making sure that those cores are as fast as possible. So I'm looking at fast architecture 4-core processors or fast architecture 6-core right now. And the more you're doing in 3D and visualization, the more I would cheat towards the 6 cores.
Okay, Robert, next question. Can you talk about CAD Workstation performance in general in terms of mobile versus desktop? So in other words, if you opt to go with a mobile workstation, you can clearly pay a little bit more, but will you be making any other types of sacrifices in terms of performance?
Good question. Let me qualify that just a little bit. Right now, mobile workstations are just as capable as desktop ones up to a certain point. If you wanted to run a high performance i7 core, like a 6700K processor, you're up over 4 gigahertz. You want to get 64 gigabytes of RAM in it, NVMe technology solid state drive. You can get all of that in mobile workstations. Now, where you start to lose it is you won't be able to get dual processor cores. You won't be able to fit maybe more than 1 terabyte of storage. You may only have limited options in terms of your graphics. So if I have to generalize, I would say if you're doing CAD and modeling, you're probably going to be able to run on a mobile workstation just fine. Really no sacrifice. But once you start getting into the really high-end, analysis, rendering, video editing, those types of things, that's when you're going to start to see the desktop workstation pulling away. So it's really task-oriented. And I see a lot of companies now that are going to mobile workstations. Now, I will say that a mobile workstation, as compared to a desktop with exactly the same specs, the mobile will cost a little bit more. But if you have traveling people, you don't have to mess with docking stations and other logistics. So it may just make more sense to go mobile at that point.
Great, thank you.
Okay, our next question is, do larger models require more video or more RAM typically?
Could be, is the answer. A really good way to think of it is, or the general thing I use is, it takes about 8 gigabytes of RAM just to kind of get the machine booted up and, get your browser windows and your email clients and just, all the stuff that we have to have on our desktop these days. I assume 8 for that task. Then each CAD application that's open is going to take something on the order of 1 to 1.5 gigabytes. And then the model, you can safely say your model size times about 20 is usually a fairly decent barometer to use. So if you're using some very large Revit stuff, you're pulling in submodels from people around teams, and you're having to load all this stuff in and keep it memory resident, you could very well require more. Now, from a graphics point of view, it really only has to do with what are you trying to do with the graphics and at what frame rate. So if all you're doing is doing 2-dimensional CAD, or you're doing 3-dimensional modeling, even in something like a mechanical modeling tool, if all you're doing is statically looking at the model, or you're maybe doing some hidden line removal, yes, the graphics card matters, but it doesn't matter nearly as much as if you're trying to do real-time rotation, show and tell, client demos. At that point, you really need to look at the processing rates and the available RAM on the graphics card. So if all I'm doing is basically static modeling, the 2 GB card should probably be fine. But if I'm doing a lot of real-time rotation, show and tell stuff, I've stepped up to 4K, I would consider the 4 GB professional graphics as a practical minimum.
Okay, great. Thank you, Robert. We have a lot of questions related to the different intricacies of, what cores versus other, other specs for specific software applications.
Yeah, for specific software applications and how they utilize cores, it's actually vexingly difficult to get that information. I mean, you can talk to workstation manufacturers, and quite a lot of times, they actually have to load up the software and start looking at it. Now, what I do, and it's not forensic science, but you load the software on and you pull up Performance Monitor, and you just start looking at your memory utilization. And it's pretty easy to see if your processor is maxed out, or if your actual RAM paging space is maxed out. Then it's pretty easy to see that your computer is being overly taxed by the application. Most of these processes that we use in CAD tools really are working principally on one core. So the number of cores really is less important than you would think. The speed of that boosted core is the most important factor. Now, if you're doing video editing or some other things where it's spawning off different processes and it actually is using multiple cores, then more cores could be applicable. But you're probably going to have to dig with your software vendor to see how they utilize that. I can't make a general recommendation. I just don't know that much about specific video editing tools. That seems to be where most of the problems lie.
Well, with that, we are officially out of time. Thank you so much, Robert. We appreciate everything that you've done for us today. We will review all the remaining questions and do our best to follow up with folks directly. In the meantime, if you could advance the slide, Robert, here are some links to additional resources that you might find valuable on Cadalyst.com. We've set up a page where you can find a copy of today's slides, the Workstation ROI Calculator worksheet, and links to other information. Please see Cadalyst.com/CAD Management and watch your email for a link to the recording of today's event when it becomes available within the next 24 hours. Thank you again to our generous sponsor, Fujitsu, and last but not least, a big thank you to Robert Green for the great presentation today, and thank you to all
guys.
attendees
Hope you enjoyed.
For your time and your interest. We appreciate that very much and hope you enjoyed this event. Thank you again, and everyone enjoy your day.
Bye.
Bye-bye.